Hello students, this is Jayant Mane from Findalex Academy, Ratnagiri. This is ninth lecture from Transient Control, and now I'm going to tell you about how we can calculate energy loss in any transient operation. So transient operations are starting, braking, speed change, speed reversal. So every drive takes some time to perform these operations. Now that time depends upon some parameters, so that we are going to derive. Now let's consider the fundamental torque equation. So it is the same equation which we have derived, just the difference is okay, currently the same equation is written, just the term omega m is written here. That means this torque must be function of speed. Load torque as well as motor torque must be functions of speed, and obviously they are the functions of speed because we always plot a torque speed characteristic and write equation of torque speed characteristic. So the equation of torque speed characteristic, if for any motor is written, in that case it is this same thing which it is written, torque which is function of speed. Okay, for example, consider a shunt motor characteristic. Torque on x-axis and speed on y-axis. It is the dropping characteristic like this. So if I write equation of this characteristic, it will be obviously equation of straight line passing through this point, which is no load point. So that equation written will be this T of omega m. Similarly, any load torque, suppose a windage torque, suppose this shunt motor is driving a fan load. So this is the characteristic of fan load, windage torque. This is the operating point A, where both characteristics intersects. So it will operate on this torque and this speed like that. So this is it. So if we write equation of this load torque with respect to speed, in that case also it will be this one. Okay, so just rearranging the terms to get dt term. So dt is difference in the time, and we have just rearranged the terms. Now to remove this difference of time, integrating on both sides, then we get just equation of time. So now we got j integration omega m to m omega m2, omega m1 to omega m2 d omega m by t minus tl, where omega m2 is 95% of final equilibrium speed. Okay, meaning that suppose there is speed change. Transient operation means speed change from, suppose it is starting of the motor. So right from 0 to some value, if the speed is changed, in that case suppose the final value is some 1000 rpm, then while taking limits here, the omega m1 is 0, whereas omega m2 is, if final speed is 1000 rpm, then we have to take omega m2, not the 1000. If we take 1000, then the answer will be infinite. Okay, you can also try it, okay, while solving the numerical. So if you take final speed as this one, then it is infinite. Then you have to take actually 95% of the final equilibrium speed. That will be the omega m2. Okay, now reason behind this is a transient equation. This is a transient time. Okay, here we are calculating the transient time of the drive. Means suppose if the torque equation is known to us, load torque equation is known to us, inertia of the machine is known to us. Just in the previous lecture we have seen how we can measure inertia of the machine using retardation test. So all this data is known, and then if we intend to change speed from one to another, it could be starting, then initial speed is 0 and final speed is something, final speed okay, omega me equilibrium speed is something 1000 in just previous example I have taken. So like that you have to just put these limits, and then you will get the transient time. Now if it is speed change means suppose from 1000 rpm the speed is reduced to 800 rpm. In that case again the 1000 rpm is omega m1, but 95% of 800 is omega m2. So if you put like that, you will get the time required to change this. Now why we get infinity if we put final speed here directly, equilibrium speed here? The reason is any transient theoretically is never over, is never zero. Okay, because it depends upon how closely we look at the transient stages, transient condition. Means suppose the speed is increased from 0 to some value. Now initially just by just by naked eyes we can see the change in the speed, but once it goes near to 1000, we don't know whether it is 999 or 999.9 or 999.99999, okay, like that. So how precisely we look at it. So means theoretically it takes infinite time to reach to 1000 rpm exactly. Okay, that is why that equation will give you infinity if you put final equilibrium speed as it is. Instead of that you had to put 0.95, 95% of the equilibrium speed. Now what is shown here is a graphical method. It is a graphical method of calculating integration. So whatever mathematically you are doing here using suppose calculator, same can be done graphically. So this curve is this quantity j by t minus tl versus speed, and just take the initial speed and 95% of the final speed and just measure the shaded area. The shaded area is nothing but the time, means integration. So time required for transient can be calculated, as well as the energy dissipated in motor winding during transient operation also can be calculated from this time. Actually this is the main purpose, because we know that during transient time huge energy will be lost into the windings. Due to that the temperature of the motor will rise and it may damage the motor. For example, we know that starting current is normally 5 to 7 times than that of the normal if starters are not used. So that is a transient operation. If without starter the motor is started, in that case it gets burnt, isn't it? Due to overheating, obviously, and this is the reason. Energy lost in the transient operation. So therefore we limit the current of the motor to twice or 1.5 times the rated, and then we design the starter according to it. And then we start the motor, operate the motor, and in that case motor will not burn. Same case is there for stopping the motor using electrical braking methods, as well as reducing the speed or increasing the speed if the acceleration is very high. In that case huge losses will be occurring into the motor windings, and they may damage the motor windings. So while selecting the machine, we have to already study how is the duty cycle of the motor, means how the load is worked, whether it is started with some high current, whether there are so many speed changes, and whether the braking is there with within some less time using electrical braking method, or there are several speed reversals. So all those we have to take care, and energy lost into those operations have to be taken care, and then we can calculate the motor power rating. So that part we'll take afterwards, but for the sake of knowledge I'm telling this. So this is how we can calculate energy lost. So for that you must know the resistance of the winding and current through the winding. So it is just I square R T, isn't it? In other words, if we integrate this from 0 to T, where T is the transient time. So in this way you can calculate transient time and energy lost in the transient operation, and then it helps us determining the motor power rating, as well as determining what will be the time taken by the drive for that particular transient operation, means starting or stopping or speed reversal or speed change, whatever is the operation, transient operation.